Before we move on to exporting and caching our particles, I want to bring your attention to this simulation, which in the end was the one that I liked the most. Here I'm only using the erosion. I turned off the repellents and the density control, just because I feel that these tendrils tend to look more organic and less uniform. But still there's something here that I'm not extremely happy with, and that's the spray that's being generated with the collision object. So notice here, after the rigid bodies hit the water surface, we have spray being emitted with quite some force. So it's rising very high, very fast. And this is something that I would want to control. Take a look here. We have too many particles in the air. I can also see a few defined streaks being generated. So the way I'm going to avoid this is by controlling only the spray particles with a few pop forces. So let's go back to our simulation. And if you look closely, the third input is called particle forces. So I will connect a merge node to this input. This will allow me to connect several pop forces at once. So first of all, I will start with a pop drag that by default we know will add drag to every single particle in the simulation. So in this case, I will use a very simple vex expression to apply the drag only to the spray particles. So click here on use vex expression. First of all, I will reduce the air resistance to 0.2. The default value of 1 is usually very high. And now I'm going to multiply this value, the air resistance, by the value of the spray particles. So just to recap, if you go to the geometry spreadsheet, below geometry, you will find the point attributes. So currently there are no point attributes because we are on frame 1. So I will play the simulation just a few frames until we start to see these values appearing here. So the first white water particles are being generated around frame 33. Here we have some bubbles start to appear. And we should also have by now some spray particles. So if you notice here under the spray attributes, the particles that have higher values will also have the higher air resistance. So back into my vex snippet, I will multiply the air resistance variable. And to find out the name of the variable, you can hover your cursor on top of this parameter. So it's called air resist. We will multiply this variable by the amount of the spray value. And that is all there is to it. Now, another very interesting thing that I want to do is add a little bit of air and turbulence, again, only to these spray particles. So this time I will add a pop force. I will connect it to the merge node. And let's take a look at the properties that I want to use. First of all, we have force that is divided in force X, Y, and Z. And I will also add some noise amplitude that has the amp variable. So I will scroll down to where the vex expression is. So turn on the use vex expression property. And now we will type the following code. Amp, which is the amplitude of the noise, times equal the spray attribute, and semicolon. And finally, the force X, so type force.x, which in this case is the X component of the wind, times equal at spray. So this would be the value of the spray attribute. And it seems I have a typo. Here I forgot the E. So press Ctrl Enter to evaluate again. And now all we need to do is increase the amplitude. So this is the noise that will be generated. And the force, this is the wind that will be created on the x direction. So with a few lines of vex, we can have a huge control over which part of the simulation we will be adding these forces to. And let's take a look at the result of these changes. Again, I have a flipbook already generated. And now if you take a look at the spray, first of all, it's not rising so high. Also, we don't have those very defined streaks. And we will also have a very subtle wind and noise being applied only to the spray particles.